Go into our slideshow. It's okay. Okay, so frequency distribution. What does the word frequency mean? How often? Yes. Right. I do something frequently. That means, it also means a lot, but sort of in general, but it's how many times something happens. So that's all we're doing today is really counting. We're going to have some data. How many times does that sort of data occur, right? So we can use these techniques we're using with both qualitative and quantitative data. Okay. Yes. So then that's what's called a relative frequency. So exactly, good. Um, so we're going to calculate frequency itself is the number of times it occurs. Relative frequency is the percentage of time something occurs. And then I'm going to show you, we're going to basically do in the activity one frequency table, but from it we'll actually be able to produce multiple graphs. Okay. So what is a frequency distribution? It's taking a group of, it's taking some data and listing the frequencies for every piece of data. Now, even if we have discrete data, it may be that there's just one piece for each one. So that's not, you're just basically repeating it. So what we do typically with a frequency distribution, we've got numbered data, is we invent something called a class. So in this, let's see, I don't even know what this data is, but for whatever it is, the class sizes, first one is 1 to 5. So any data that is between 1 and 5, we count those, and there is evidently in the set of data, there's 5 pieces of data that are between 1 and 5 inclusive. So 5 would go there, 1 would go there, anything in between, right? 6 to 10, there's 8 pieces of data. Now, again, we don't know if it's 6, 7, 8, 9, or 10 with this setup, but we know that in that block, that class, okay to talk, but at the same time, make sure it's about this. Okay, it's okay. So again, we're just counting them, and we'll go through the process from the start. But this is what a frequency distribution looks like, and that's what we're going to come up with. In itself, it tells us, hey, 6 through 10 and 16 through 20, those things occur the most. Both of them have 8 items in there. Again, we don't know exactly which ones they are, but it does help. So we have a lower class, and doesn't mean it's low class, just lower. The bottom of the class boundary and the upper class boundary or limit, okay? And we're going to see how we calculate this. Over here we have the frequency. You can also see the class width if you take the lower class boundary of 1, subtract it from the other, that gives you how wide the boundary is. So 1 to 5, 1, 2, 3, 4, 5. And it's because we're counting the bottom one. So if you took 5 minus 1, you get 4. But that's not the class width. The class width includes 1 and 5. 1, 2, 3, 4, 5. That's why I like to use my fingers. I'm sure it's a width of 5. So remember, when you're doing these, you're taking the lower class boundary minus the lower class boundary of the next one, and that gives you your class width. So we've got a class width, we've got a lower limit, upper limit that gives us our class, and then we go through and count how many times those numbers occur in the data. Oh, let's back up. And going from the lowest, so class of 1 up to 30, that would be a minimum and maximum data. That's our range. So we're going to see we need to calculate that in order to set these things up. So you take the biggest value minus the smallest value, that gives you your range of values. So this is the example. Actually, I've got this data will be in a Google Docs or Google Sheet. I have it in an Excel right now, but so that you don't have to enter all the data. But this is data we're given. This is cell phone screen times in minutes for 30 US adults. So someone spent 200 minutes, and I don't know if it's for a month or a day, on a recent day. 200 minutes in a day, is that a lot of time? I don't know. How much screen time they had? Probably Not that much, yeah. Throughout the day, yeah. Some people are up at 400. We can see a maximum here for 405. So some people use it more than others. Anyway, that's what our data is. What we're going to do is we need to decide on the classes, and it's not a set rule, but usually it's between 5 to 20. If you have too many classes, it's not going to give you much information. If you have too few classes, it doesn't help much. Okay, so somewhere between 20 to 5. A lot of times when you get into the homework, they will tell you what the class width or how much the class is. Then we're going to need to find the class width for each individual. So we take the range, we're going to see you take the range of values, divide by the number of classes, and that's going to give us our class width. Okay. We always round up to the next one so that the class width is big enough to contain the smallest to the largest. So if you get, say, 21.2, what you're going to use for your class width is not 21. You're going to actually go up to the next level, which will be 22. Even though 0.2 usually would round down, we always round up. Okay, so even if it's 21.1 or 21.02, you always go up to the next one, okay, because it has to be an even number. And you'll see how that works. Okay. So what we're going to be given is they want 7 classes. That's what they're telling us. So how do we go about finding these 7 classes? We're going to do it primarily by hand. Let's see if I go here. And again, what we're going to see is that, I have to do 2 things first. Sorry, I try to do too many things in the morning. Sometimes I don't want that. Oops. Need this, my tablet. Okay. Now the tablet's going. And again, what you're going to see is in the Google Docs and stuff, all the things we're doing by hand will be automated, but you'll have to use a few formulas. But Google Sheets, Excel, it can look at this data, because a lot of times you're just looking at data, it might be hard to pick things out. But the class width, what we have to do, we have to pick out the largest. So again, we look at here, I see 405. And I believe that's the largest because I was working with this information earlier. I need the smallest value, and I think it's 155 here. Is that seem about right? So this is what we call the minimum, and we'll use these features in Google Docs, and this is the maximum. Okay, how do we find the range? Subtract, right? Max minus the min. So that's going to be 405 minus 155. Plug it in a calculator, or do it in your head, or let Excel do it. It's 250. Again, because I just did this at home. So subtract those 2, you get 250. So that is our range. To get the class width, what we're going to do is take our range, biggest to smallest, and divide it by 7, because we want it in 7 groups, right? So that's literally what we do. That's what division is about. So class width, next calculation, is 250 divided by 7, which doesn't go in there evenly. You get 35 point something. Let's see. I use my NumWorks calculator. And just the calculator part, 250 divided by 7 comes up with 35.71. And so what is our class width that we should use? 36, exactly. So we're going to say the class width, well, I'll just click round up to 36. Okay, because that was in, yes, sir. It will. And they'll just tell you, and sometimes it's kind of, you want, because eventually we're going to take this and turn it into a histogram, and you just kind of want to make it look nice. So you might say, oh, 7, oh, that was, maybe I should go for 8 or 9, or maybe I'll do 5. So there's no hard and fast rule, except if your boss asks you for 7, you make 7, right? Or if, you know, the homework asks you for 7, yes, that's what we do. But there's nothing sacred about 7. It just depends on, a lot depends on how much data you have, what the range is, those kind of things, and how much detail you would. The smaller the class width, the more details you're going to get, right? Because you'll have more bars. The smaller the width for the same amount of data. So if we had 10, our class width would be smaller. In fact, our class width would be about 25, right? That's an easy one to do. 250 divided by 10 is 25. And so that would be a class width of 25, but there would be 10 bars. And again, it gives us more detail, but it might also look more busy. Okay, so far so good. Okay, and again, I'll show you how to do it with Google Docs with formulas where you just got the data, you say, okay, find all this stuff for me. Now we need to construct the frequency distribution. So we've got to get the class limits. Remember, there's a lower and an upper, so we'll set those up. For the lower, you just take the minimum piece of data. So we've already got that, the 155. And then what we're going to do is we're going to add the class width to the lower limit, and that gives us the lower limit of the next one. So just to kind of, here is the lower limit of the first one is 155. That was the minimum. We're going to add 36 to that. So 155 plus 36 gives us 11. Carry the 1, that's 8, 9. That's 191. So that would be the next lower class limit. Okay, so the class width gives us the next one. But here's the lower limit. The upper limit, once we've calculated that, we subtract 1 from so this 191, we subtract 1 to get 190. That gives us the upper limit. I'll just put a subtract 1. Okay. And so you kind of go through and you'll calculate all the lower limits, 36 plus 191. Again, it's mathematical, but if you use Google Docs, it'll do it all for you. So this is going to be 7. 6 and 1 is 7. 9 and 3 is 12 or 11, 12. Carry the 1. 227 is the lower limit, so this must be 226. Okay, so we go ahead and build the table that way. So it's kind of like you actually calculate the lower limits. To get the upper limit, you just subtract 1 from the next lower limit. Okay, and we'll have this. That's right here. So this is kind of a recipe. Find the remaining upper class limits. We're going to do that. But we'll see also, when we use Excel, we do this all with formulas. So as those change, we're fine. So lower limits 155. We added 36. We got 191. Subtract 1, you got 190. And again, they just keep adding 1 or 36. You get all the lower class limits, and then you can subtract 1 from the next one and get the upper class limits. Now, the only one you can't really do that for is the 406. I guess you could see what the next class limit, 371. If you add 36 to that, you get like way too big. Well, you get 407. And remember, what was our big, sorry, see, I was thinking at the same time, 407. What was our maximum piece of data? 405, right? That's dyslexia for you. You're always thinking ahead, so then it starts writing it. So 407, we know 405 is all we needed. So if you subtract 1 from that, that gets you to the 406. So we're able to fit all our data into these bins. So far, so good. Okay, and again, you'll see if you do the extra credit, you'll be able to do it all with technology. And we go. And So this is just another slide. Yeah, 190 plus 36 gets you. You could also calculate them this way. Once you have these upper limits, if you add 36, you'll get the next upper limit. So you, more than one way to do things, right? And you kind of feel the way that feels natural to you. Whatever feels more natural to you is going to be more enjoyable, and you'll do it. You can do it somebody else's way, but sometimes that's always gives me headaches. Do it the way that's best. So we've got all the limits. And then this is the hard part. Again, this is where the formulas in the Google Sheets will be very helpful. Otherwise, it's very tedious. What we have to do now is kind of go through this stuff. Okay, here's 55. I'm going to cross that off. I need to find all the ones between 155 and 190. So I just have to, oh, here's 165. That's in the range. Where's the next one? There's 168. There's 195. That's too big. So there was 3 that we counted. So you could make 3 tallies and stuff. And you would go for each of the classes, the class widths, and just tediously go through. And this is where I always make mistakes. I count 1 too much or 1 not enough. But the way you check is at the end, you add them all together. Since we have 30 pieces of data, we were told that this is data of 30 people. We should have 30 frequencies, right? If we have more than we counted, double counted. If we don't have enough, we missed something. Again, you're going to see the use of technology is great for these types of things. It's not so tedious. And once you get it set up, you can change your data and it'll all do it for you. Okay, so far so good. So we've got to start on this, and now you could also, sometimes we use calculation, we use the midpoint of the class. So it's a way of, sort of a lazy way of trying to calculate things. Since once we've got the frequency table, if we get rid of the data, we don't know what those values are in the middle of the class, right? We know there's a width of 36. So there's 36 possible values in there, but we don't know if that's the beginning or the end. So one way to do it is to get a class midpoint. So you take the lower class limit plus the upper class limit, divide by 2. Kind of remember that whenever you want to get half of something, add the 2 ends together and divide by 2. You always get half of. You get halfway between them. Oh, there was supposed to be something here. Let's go back. So for the first midpoint, what you could do was 155, and the other was 190. We divide it by 2. This will give us the first midpoint. That is 200, 300. Let's go from the back. That's a 5. 9 and 5 is 14. Carry the 1, so that's 345 divided by 2. I don't want to do that in my head. I probably could, but I can't teach and do math at the same time. 172.5. At least my math, one of the two things, my teaching will be bad or my math will be bad. But if I use a calculator. So there's our midpoint, and we could do the 0.27 or 0.5. A lot of times what we would do is say that, well, we treat it as if there was those 3 items, a frequency of 3 in that class, we're all at 172.5. So we're going to see we can find averages. It's a quick and easy way, especially if we don't have the data. It's the best we can do. It's going to give us an estimate. You could. It depends on, again, it's aesthetics. I don't like decimals. Let's get rid of the decimal. Let's just round it up. Close enough. It's going to be an estimate anyway, right? So, or you might be someone, I really like to be as exact as possible. So it's okay to have it there, but it's also okay to round it. We look at the instructions if we want to match their answers. But if it's our personal thing, it's our personal preference. I don't like decimals. Let's call it 173. That's fine. Okay, so far so good. So we can calculate a midpoint. We'll use these later on. As you were mentioning, percentages come into this when we calculate a relative frequency. And what we do for each class is we take the class frequency divided by the sample size. How many pieces of data did we have? Anybody? 30, exactly. So yeah, we could always look back if we had to. But So what we're going to do is we're going to take each of the frequencies divided by 30, and we'll do that. And then there's a cumulative frequency, and again, I'll show you this in the other one, which is just adding them as we go along. So you start with the first one is the frequency, and then you add the frequency of the first class to the frequency of the second class. So it's kind of like I call it a running total, right? So we'll do both of these. Well, you could find the midpoints. Again, we're not necessarily, they did all the work for us, but relative frequency, right? So for the first class, it's got a frequency of 3. So 3 divided by 30 is 0.1 or 10%. You can change these to percentages. Again, just what do you, I like percentages. I think they're more beautiful than decimals, but hey, that's a bias, right? That's a bias. And then you've got your cumulative frequency. Well, we just started counting, so we've got 3, right? The next one, we have a frequency of 2. So again, we do the same thing. 2 divided by 30 is 0.07 or 7%. And then you take this frequency 3 plus the 2, and now we've got a total, as we sort of the running total, we've got 5 frequencies accounted for. So it's sometimes beneficial to have this cumulative frequency, because you can see once you get to the very end, which they didn't here, we'd have to go to the next page, you'll see that your final cumulative frequency is always the total number. So the last one will be 30. And that's sort of a way to check to make sure you've got all the data and you don't have extra, those kind of things. But again, you're just taking the frequency divided by the total. That gives you a relative frequency. And what we're going to see is we can use those for things called a pie chart. So we use each of these numbers in different ways. Okay. So we can do that. And again, sometimes we need the midpoint. Sometimes it's not important. Again, here they didn't round it. They left the decimal on. That's fine. I don't care. Take it off. Like I said, I would change. I would put relative. I would put percentages here. They all add to 1 or 100% if you're using percentages, right? So that's another thing to check is sometimes you get a little bit either over or under 100% because there's some rounding. If you've got a large data set, some of these relative frequencies, if you round them, right, there's going to be slight rounding errors. You might get 99.99 as your total relative frequency. It's just a rounding error. And then you've got your cumulative frequencies here, and notice the last one is the total number of data. So we got 30 pieces. It's got to be 30. So these are ways to kind of check it, but this is what a complete frequency table looks like. I'm not, well, I don't know. I'll get your opinion. Should I, in my current activity, I didn't do the midpoint. Do you think I should do it in the midpoint for the Google Docs? How many say yes? Okay. One person wants it, we'll do it. So we'll put it in there. I'll show you how to do it. It's extra credit. If you don't want to do it, you just, you can say, remember, you only have to do 90% of something, so that's less than 10%. You could choose not to do it, but I'll put in the slides how to do it. Okay, might as well. How are we doing on time? We're good. Okay. Because actually, if we get all the way through this work, which I think we will, then tomorrow we don't have any lecture. This is all the course. So this afternoon I'll develop the extra credit part using the Google Docs, and then we basically have a day to work in class.
Is the extra credit gonna be a time? Like, you know how like the homework doesn't have like a limit?
No, it's whenever you want. Okay. Again, fit it in with your, it goes with chapter 2. You should probably do it along those times, but yeah, you can wait. You fit it in. That's what I want you to. One of the best lessons you learn from school, actually, this is what my grandfather on my dad's side used to say. He said, college teaches you which book to look in. Now we have to update that. We don't usually look in books, right? We look on the websites or something, so that we do that. My addition to that is college teaches you how to think and do your own thing. I think too much of schooling is sort of micromanaging. You have to have it done by this time. And if you see some of these systems, if you're a minute late, it's not going to accept it, right? What's all that about? You have to learn to manage yourselves. you have to learn because you're enjoying it. You know, you have to find the joy of learning. How can you ever do that if you're always just doing the things that you have to do when they have to be done? When you get choice, then I'll get to it when I'm ready for it. And then I'll enjoy it more. And then I'll do more of it. So it's kind of a, people say, oh, you're being too easy. I says, no, it's not really. I'm being sneaky because I know if you enjoy it, you'll do it a lot. In fact, you'll start asking me, can we have some more stuff? This is fun. Okay. Okay, so anyway, histogram. So now we're into the graphs, and again, we'll meld this all into, once you've got a frequency table, that's what we use to do all the graphs. And again, that's the beauty of Google Docs, Google Sheets. It will make all these graphs for you, but I want you to understand sort of how they do it. So one thing is a histogram we use a lot. You could call it a bar chart, but when they're touching each other, that's a histogram. And what we're going to see is that you'll have your data values on the bottom. So these will be the measurements of, for our example, the screen time. So there'll be the usually use the lower class limits down here. The y-axis is going to be the frequency, and you can do two different ones. You could do just the numerical frequencies, or you could do the relative frequencies, or both. So sometimes you do them side by side. The graphs themselves will look similar, but the scale is different. So sometimes we use the relative frequency if we're using it to compare to other groups, right? Because, okay, we had 3 in this group, but if we have a larger sample later on, how can we compare them? We compare them by percentages, right? We had 10% here, and even though this was a larger group, we might also have 10%. So that's an easy way to do it. And with the class boundaries, the reason we do that is that the bars, the boundaries must touch on a histogram. And so typically the way I'm going to set it up to format is I just use the lower limit of each one, and then you know that the bar's running right up to them. Okay, so maybe we'll do this with the class boundaries. So the idea of thinking of this on a histogram is sometimes you would list it like this. Again, going, so it's very clear our data is 155 to 190 is inside here. We don't have any decimal numbers in there, but you can calculate these class boundaries, and all they've done is, because they want them to touch, so see 190.5 goes to 190.5, so they're touching. But at the same time, what I do is I'm just going to list these, or you can list it 155 to 190. Okay. But you're just subtracting a half or adding a half to kind of be inclusive that that's what the data is including. And then what they do, there's a couple different ways you can do this. So one way of doing it is you could use the midpoint on your graph. And I'll show you how you can actually do multiple graphs. So once you've got your frequency table, you could make this one, or with a quick change, you could make the other one. You could also show the lower and upper limits for each bar. So 154.5 to 190.5 here. So that's another way to do it. For me, I think it looks prettier if I went like 155, 191, to, you know, again, without the decimals. But we'll show you a couple different methods. You choose which one. Again, with the extra credit, it's about just following through and doing it. And again, having choice as well. Okay, does that make sense though? And you see, when you get it like this, you get a visual. So you don't just get a bunch of numbers that you have to look at patterns. A lot of us, some of us, I don't know, maybe a lot of us, are visually oriented. So you see this picture and you see the patterns, and it's easier to see it when you see a picture, right? Versus just numbers. Some people are good at looking at numbers and picking out the patterns. So the thing is, we do both. We've got the table. If you like numbers, you could do it that way. If you like pictures, we'll do it this way. Okay, so this is a frequency histogram. And again, you could see some things. Yeah, it looks like 2/3 of the adults are spending more than 262 minutes. So we got 262. You can kind of visually see, yeah, there's a lot more than that. It helps you to do that. Frequency polygons, I don't like them, so I don't teach them much. I haven't really ever seen them used much, but all it is it's taking the midpoints, so that's why they calculate that midpoint, and using it as a dot and then connecting it with the lines. The reason I don't like it is when I see these lines, it indicates to me that that's data in between it when it's really not. These lines are just there to sort of indicate trends, but to me, it's like it's not accurate because that's not what's really happening. It's not that between this one and this one that it could be any of these values. So it's kind of misleading in my point, but I think we'll see if there's any of these in there, but I'll just give you the freedom. You can skip anything about a frequency polygram. Again, I don't really see them used much, and they're misleading when you use other types of graphs because you're actually connecting and you're going to use those points in between to kind of make estimates. When you do it with these, it's bogus. Okay, so we'll skip over that. Now, here's the frequency, here's the relative frequency. Remember, these are percentages. So we can do exactly the same thing. Well, they're doing a polygram. We don't want to do that. But we could also do a histogram with the relative frequency as our y-axis. And I think they do that next. Again, this looks ugly, doesn't it? I mean, and it's misleading. It's just kind of, those lines are not data. When you see them, as so that it gets at the mathematical part of me. It's just not right. So we should skip over that. We're going to use some technology differently. What's in there? You could use relative frequency. Again, it's an easy click over. Instead of using the frequency, you use a relative frequency as your data, and you get a very similar looking histogram, but over here you get the percentages rather than that. And it's a real quick change when you're in Google Docs to actually can make both of these real quick. So we'll do that. Then when you compare the two, they look very similar again, but this one with the percentages is maybe more useful, so you can compare to other samples of different sizes. We're going to do some pie charts. Pie charts use relative frequency. So what does the pie represent? The circle, 100%. And so you're going to get slices based on the percentages. We will have you create one of those as well. Here's some data. They give us a frequency table. We're going to use the same one, so use one. You get the relative frequency. How many degrees are in a circle? 360. You multiply that by the relative frequency. That tells you how many degrees are in the pie. But again, we're going to use technology that will do this for us, because I'm not real good at drawing these things. But we could do it by hand. But again, we use technology, and we'll see that we can just display it differently. And with the pie chart, you can see, this one's the big one. It's about half of the circle, bachelor's degrees. Okay, so that's what pie charts let us see. Pareto charts, again, I don't like. They're just putting things in order. They arrange the graphs from largest to smallest. So sometimes those are helpful. Again, I think we don't even do that in the homework. If there is, I might show an example. But I have not really seen that used all that much. Okay, and it's only with data that is not of importance, and it's just sort of because it looks prettier that way, right? So you could notice this data does not have any order to it. So what they've done is they've just gone from the most frequent to the least frequent to just make it look pretty. So that's all a Pareto chart is. We're going to do scatter plots later down. So again, we'll skip it for now, which is great because we're running out of time, and we don't have to do any of this stuff. And we're not doing anything with the time series charts. So we're just going to do frequency charts. This afternoon, I'll finish up. I'll make the video. So don't try to do the extra credit yet. Let me finish that up this afternoon. And then tomorrow, we'll have an open day where we can work on homework, we can work on the extra credit, whatever. When we do have work days, if you have earbuds or headphones, it might be helpful if you want to watch videos, so that we're all watching different videos. It's really hard. So bring those along, and we're all good. And we got done just in time. Thank you.